Welcome back to the Energy Academy Australia. Today we're exploring how electricity moves across the NEM. After electricity is produced, it then has to be transported from the power stations to the consumers, homes, businesses, and industries. This is done through high-voltage, long-distance transmission networks and lower-voltage distribution networks to deliver the electricity from local substations to the end consumer. The transmission networks, in particular, are vital for allowing power flow from generation from more remote areas of the NEM to cities that form the majority of demand. Each region of the NEM has a transmission network managed by different transmission network service providers, or TNSPs. There is Powerlink in Queensland, Transgrid in New South Wales, Electronet in South Australia, AusNet in Victoria, and TasNet in Tasmania. The TNSPs build and maintain the transmission networks in their area and earn revenue from network charges in consumer electricity bills. The regulator sets the network charges, providing a maximum level of revenue to the TNSP, which encourages them to reduce costs and improve efficiency. For instance, when a TNSP wants to build new transmission lines, it has to conduct a Regulatory Investment Test for Transmission, or RITT. The investment test needs to prove that the investment will benefit its consumers the most compared to other alternatives. On a more local level are distribution networks, which deliver electricity from transmission substations to the end consumer on lower voltage lines. Distribution network service providers, or DNSPs, also have regulated revenues and costs like their transmission counterparts. Interconnectors link the different transmission networks of the NEM, allowing states to transfer electricity to each other. For example, the Bass Link interconnector links Tasmania across the Bass Strait to Victoria on the mainland. This allows Tasmania to supply cheap, dispatchable hydroelectric power to the rest of the NEM. As renewable energy continues to grow in the NEM, new transmission developments are essential to allow solar and wind farms to meet demand over long distances. AEMO and state governments have identified renewable energy zones, or REZs, as areas of high priority for future transmission upgrades to allow for new wind and solar generators where they are most suitable. New interconnectors are also planned to improve links between the different regions of the NEM. These include Energy Connect, which will add 800 megawatts of transfer capacity between New South Wales and South Australia, and Marinus Link, which will add another link between Tasmania and Victoria to complement Bass Link. Long-term development of the network is important to meet Australia's future needs, but equally important is the day-to-day operations of the system. In the next episode, we'll talk about how the market operator places dispatch instructions and why network constraints mean that generators are not all treated equally. I'll see you there.